Hi again. Today I want to take a look at something called solution stoichiometry. To make the most sense of this program, make sure you've watched an earlier program on reacting masses before you watch this one. To do this, I'm going to look at two sample problems. In my first problem, I have a small piece of sodium, which I'm going to add to 355 cubic centimeters or milliliters of water. We've seen this particular reaction before, sodium added to water, making sodium hydroxide and hydrogen. We would have seen this back in unit number 3. Anyway, my particular question asked me to determine what the concentration of the final solution of sodium hydroxide is. I'm going to list the information that I'm given also here. I know the mass of sodium, and I also know the mass of water. Now, let's take a look at how you know the mass of water. We have the volume of water, 355 cubic centimeters, but water is unique in that its density is 1. That meaning 1 cubic centimeter equals 1 gram. Now this only holds true for water. So if I have 355 cubic centimeters, I also have 355 grams of water. Now looking at this question, I recognize the pattern here. I know information about my two starting materials. That means this really should be considered like a limiting reactant problem. So I'm going to start off with the 355 grams of water, convert that into moles of water by dividing by the molar mass, and then apply the ratio going over to the substance I have of interest, which in this case is sodium hydroxide, and the ratio is 2 to 2, or 1 to 1. Hence, I would make 19.7 moles of sodium hydroxide. Now I'm going to work with the sodium and determine how many moles of sodium hydroxide I would make from it. So again, dividing by the molar mass, I arrive at 0.0187, the ratio 2 to 2, and clearly I can see here from this example that sodium is my limiting reactant. It makes the smaller amount. So I'm going to ignore the information then about my water when determining the mass or the moles of sodium hydroxide that I make. Now, working with the moles of sodium hydroxide, I'm going to determine the concentration of that solution with knowledge of the number of moles and the volume. You'll notice here that the 355 cubic centimeters I converted into liters or decimeters cubed prior to putting in the formula for concentration. Anyway, solving that and rounding it off to 2 significant digits, because my mass of sodium has 2 significant digits, I get 0.053 moles per decimeter cubed as my final answer. So again, we see this pattern that we've seen before, working around the box to determine our particular solutions. First converting things to moles, then using the stoichiometric coefficients in the equation, and finally converting to our unknown. Let's try another example. This involves a technique which is called titration. So here's the apparatus that one uses in titration. And the basic idea is we have a solution of known properties that occupies the burette up above. In this particular case, I know the volume and sodium hydroxide solution that I added, and I'm going to determine some properties of the unknown solution down here below in my flask. Now, the addition of 14.3 cubic centimeters is indicated by the addition of a substance to my unknown that changes color when the end point of the reaction is reached. So in this particular case, when I added 14.3 milliliters of my base, the solution changed color. I put in an indicator in this case. The indicator I used here was phenolphthalein. That indicates the change of a solution from an acidic solution to a basic solution. Here's my reaction. You'll notice it's an acid and base reaction or a neutralization reaction, so they switch partners. Na is now with X and H is with hydroxide to make water. The information that I know, the concentration and volume of base I added, and I also know my mass of substance HX. But a little caution here. That mass was added to 1,000 cubic centimeters, but I didn't put 1,000 cubic centimeters in my flask. I only put 25 of the 1,000 in. So I didn't neutralize all 2.08 grams. I'm going to use a ratio here to determine what mass I actually did neutralize. So 2.08 was added to 1,000. How many grams M would be in 25? Cross multiplying and solving, I get 0.0520 grams. So that's the mass that was actually neutralized by my sodium hydroxide. So I'm going to replace that. Now I'm asked to figure out what the molar mass is of substance X. With knowledge of the concentration and volume of base, I can convert that volume into decimeters cubed and thereby calculate the number of moles of base, concentration times volume. The 1-to-1 ratio that exists here also means I have knowledge of the number of moles of acid. With knowledge of number of moles and mass, I can calculate the molar mass. And with that, I arrive at 36.4. Again, that's been rounded down to 3 significant digits to reflect the information that I'm given. Thanks for watching, and please don't hesitate to post any questions.